love that. All right, well, we're going to go ahead and get started here. As others join, please type in hello on the chat and your favorite dessert. I'm going to kill this jamming music. And we have actually another webinar that we would like you all to sign up for. It's taking place this next month. It's called The Secrets of an Effective Lockout Tagout Program. And I'm going to put that link in the description in the chat bar. If you would go ahead and sign up for that, that's going to happen this next month, which is Friday, June 30th at 10 a.m. We do these webinars once a month. So if you want to go ahead and sign up for that, you can go to our website, hersigengineering.com, to go ahead and sign up for that. As you all know, as safety leaders, building out effective lockout tagout program procedures is really important. So we actually offer those as services as well, but Sandy and Jordan will be on that call. They're our Lotto experts. So don't forget to share that link. It's in the chat bar over to the right. I just shared it, and it's also on our website. There's a big old fat bar at the top where you can go ahead and register right now for that. Before we get started, I have a couple of poll questions I need your help on. I need you to interact with me here. The first question, or the poll question, is: have you had an incident energy analysis done before or performed an arc flash study? So I'm going to go ahead and share that. It's going to pop up in the right-hand side, and you're going to answer. I need everybody to answer. I need everybody. Give me some of the details here. Have you had it done before? You're not sure? No? Yes? All right, I see these answers coming in. Very nice. Looks like most of us have had, not sure, no is increasing. Oh, yes is increasing. Yes is ahead of the game. We've got a lot of yeses, a couple of no's, and a couple of not sures. A couple more. Waiting on a couple more people to answer here. There you go. There you go. Majority, yes, that's good. That's really good. But as we're discussing here, there's a danger of waiting actually up to 5 years. 5 years might not be the time you need to wait. It actually might be sooner, and there's dangers, and we'll talk about that. Second poll question: how often do you update your arc flash study? How often do you update your arc flash study? Just got it done recently, no updates, every 5 years minimum. It's been longer than 5 years. I need your help here. Give me some of these answers. I like seeing these changes. See where everybody's at. Every 5 years at a minimum. Wait for a couple more people to answer. Couple more people. Let's get everybody to answer here. Very nice. Couple more. Has it been more than 5 years? Every 5 years a minimum. Couple more people to answer. There we go. Couple more. Waiting on just 2 more. Almost. Very, very nice. Okay, so it looks like most people are saying at 5 years, every 5 years at a minimum. That's awesome. The last poll question before we get started: do you complete any other electrical system studies? Do you complete any other? That's a broad scope here. There's probably multiple. So it's yes, no, or not sure. What do you mean? What do you mean other studies? Right? We're going to talk about what that means, specifics that the NFPA and the 70B require for these studies. Keep on answering. Waiting on a couple more answers, and then we'll get started here. Do you complete any other electrical system studies? The majority say yes. There's a couple that say no, and then not sure. What do you mean? We're going to get into that. That's awesome. Well, I have the pleasure of introducing to you Caitlyn Hetzel and James Weiniger. They are two of our experts here within electrical safety, hazardous energy safety, and you're going to be blessed by them speaking about these topics. Let's actually shout out to James Weiniger. He just obtained officially his PE license, which is professional engineer. So give a big round of applause to him. James and Caitlyn, why don't you go ahead and join us, and I will let you take it over. Nice to see you guys.
Good to see you too, David.
Hi, everybody. How are we doing?
Hey.
Hello.
What's up? Before I leave, everybody, make sure you have your questions ready to go for the Q&A. You want to stick around. Really good information. These two will answer your questions for you. I'll let you guys take it away.
All right, perfect. Let's get this just a little bit closer here so I can reach the buttons. All right. So we are going to have 3 different modules, so to speak, to get us started. So what our main goal today is to help you understand what electrical system studies you should be performing and how often they need to be updated or at least reviewed. So first off, there's more than just arc flash, and we'll talk about what those additional studies that you should be performing are and why each study is important in its own way. You know, arc flash analysis is something that hopefully most people have at least heard of, and if you haven't, no problem. We can definitely touch base on that a little more detail later as well.
Right.
But that's one of the more common system studies that people are talking about. It's almost like a buzzword in the industry. But there are a lot of others, and they're very important as well. So we'll wrap up with what you need to do to make sure that you're compliant and completing those studies as well.
All right.
So we have some people getting very active in the chat box, and I will try my best to keep an eye on it as we are presenting. So we already have a few questions as far as, you know, what we're covering today. So the difference between should and shall for arc flash requirements. Well, actually for any study requirements, we're going to kind of break that down. What you need to do per what the codes and standards say versus what we would consider best practice. And mind you, what we consider best practice may actually be what the code says, and you don't even realize it. So we'll get into that. And let's see, infrared imaging, infrared. A lot of people are asking if we're talking about infrared scans. That is a type of analysis, but no, that's not quite what we're talking about here. And if you want to learn more about that and what the 70B has to say, then our previous webinar is located on YouTube. Go to Herzig Engineering channel, and you can watch it, and we go in quite a bit more detail on that. But that's not quite what we're getting at here, so we will definitely cover it. What are we covering? More than just arc flash. Well, we pull from multiple codes and standards in order to get this information for you, of course. The NFPA 70, 70E, and 70B are the main ones. The installation requirements, the safe work practice requirements, and then the maintenance requirements for reliability and safety.
Right.
But there's also another standard to look at, and I'll let James kind of introduce this one.
So the other standard that I like to refer to is the ANSI NETA maintenance testing specifications, or MTS. And there's some very useful information in here regarding infrared, believe it or not, but also it's got some useful information for the studies that we'll be talking about later on in this session.
Right. Okay, so we're looking at all 4 of these books. We've got them all in front of us. Definitely recommend you guys getting some of these if you don't have them already. You know, the MTS can be purchased through the ANSI NETA.
It's the NETA store.
The NETA store. NFPA codes and standards are also available for purchase. Recommend getting you a physical copy. I've always worked better with that, but they also do online free access. Not the best solution, but you can still open it up and flip through one page at a time, or you can go ahead and get the link subscription. And that is basically like an online PDF. Like you can search for things and all sorts of stuff.
And I believe the NETA store doesn't have any kind of free access like NFPA does, unfortunately.
Right. All right. So just to get you the groundwork of where we're getting this information from. So since we are saying that we have more than just arc flash studies, do you have all required electrical system studies, some form of analysis or calculation done that are needed? And let me get this poll pulled up here. Yes, no, not sure, which is going to be kind of similar to hopefully the answers we had previously, but just want to make sure that we're clear now that we've kind of introduced this topic a little bit further. All right. Approaching about half of you answering so far.
Mm-hmm.
Give it just another few moments.
So seeing a lot of, I'm not sure what studies are required.
Well, you're at the right place.
You're
then.
at the right place.
All right, I'll give it just a couple more seconds. It's actually a pretty even mix as far as these responses.
50-50.
Yep. All right, so let's talk about what each of these codes and standards say as far as what system studies are required. The NFPA 70E mentions the need to have single line diagrams, and these system studies all stem from a single line diagram. They all start with kind of the same fundamental information.
Yep.
Some have more information needed than others, but having a diagram is really the starting place. And
for documentation purposes, it's the best way to start all your studies.
Right, exactly. So that is one thing that's going to be consistent throughout all four of these. It mentions having a single line diagram. And then the 70E, of course, also mentions arc flash studies in Article 130.5G for the incident energy analysis method. And then 130.5H talks about what equipment needs to be labeled.
Yep.
So it covers it pretty well in there. For the National Electrical Code, of course, it also starts out, we point out that it needs a single line diagram for your system, but then there's also arc flash. 110.16, it talks about arc flash. But then we see that there's 3 additional things that the 70E don't necessarily mention. What are those?
So we've got short circuit studies mentioned in Chapter 1 of the NEC. It's a pretty big one, general requirements. That shows up quite a bit all over the place in the NEC. Coordination studies as well, Article 240. Healthcare, which is 517. And also appears a little bit in other chapters as well. Reliability only shows up in an annex. Mm-hmm. So according to that, it's not really required. However, we'll get to that where it is required.
Right.
But reliability in the NEC is only covered for critical operation systems. And also, as we all know, the NEC covers arc flash, similar to the 70E.
Right. There's a note in here about coordination study done with arc flash. That is certainly an option, although it's not required to do them at the same time. That does make it a little bit easier. You can help coordinate the system and lower your hazards potentially if it all works out nicely. All right, so moving on to the ANSI NEDA MTS standard. Of course, it mentions single line diagrams as well, as well as several of the other ones that the NEC mention, just not reliability studies specifically, right?
No, there are stability and other studies in the MTS that aren't mentioned in the 70B. So those aren't really required. This is just more of a good book to reference for additional information on how to perform the studies that are required.
Right.
And there are references to the IEEE 399, which is the old Brown book. And it's now the IEEE 3002 series. And that document tells you specifically how you should be performing your studies. So that's a good reference you can go out and look for.
Right. And where are we getting our master list from? Well, it's the new standard, the NFPA 70B. So standard for electrical equipment maintenance in their chapter 6, articles 6.2 through 6.7 mention these different requirements for electrical system studies and of course the single line diagrams. So we compared this list to what the other codes and standards we look at say to try to pull that information together for you. But a lot of this information sparked because the 70B became a standard and now requires all of these studies that you have shown here.
Yep. And if you attended our 70B webinar last month, we discussed all of these studies having to be reviewed for accuracy, not to exceed 5 years.
Right. And so now we're going to go deeper into that topic. You know, we kind of introduced it at the last one. Let's dive a little deeper into this. It says not to exceed 5 years or 5 years at a minimum. Well, what would cause you to need to do it sooner than that? I think a lot of people have been pretty good about minimum every 5 years, but there's more to it than that. And so we'll definitely be diving in a little bit more. So first off, how often do you update your electrical system studies? Of the ones that we've mentioned here, now that we have a little bit more understanding, hopefully, of what it is we're talking about. So every 5 years for all studies mentioned. When there's a large enough change in the system, it's been longer than 5 years for some studies. And all those answers are totally fair because, let's be real, there's a lot to keep up on, especially since this is a relatively new change in verbiage of some of these requirements.
Okay.
Looks like about half people have answered. Pretty good mix every 5 years for all studies mentioned today. That's a good starting place. Absolutely.
All right.
Get that minimum requirement taken care of. When there's a large enough change in the system is the next one up, which makes perfect sense as well. I could answer all three. I could choose all three answers. I'm sure that's, depending on the study, right? All right, let's go ahead and move on. So to recap Module 1, we just wanted to give you that baseline of where we're getting this information so that you yourself can find it later and reference that, because that, a 1 hour webinar is only going to get into so much details. Being able to go through all the specifics is a whole different challenge, right? So now you know where to find this information, the 70, the 70E, 70B, and then bonus points if you follow the MTS.
Yep.
Okay. So now that we've listed what those studies are, let's talk about why each study is important in its own way. So we will break down what it is. What does it mean whenever it says short circuit study, for example, just real brief, how it's performed, the basic, bird's eye view, how do you get that done? And then why it's important. How do you use the information? Okay?
Yep.
So first off, every study that we're talking about starts with that single line diagram. Right? So what is that?
It should, at least.
It should, right?
It's the best starting point.
Some form of single line
So
diagram.
a diagram of single lines.
Go figure.
That shows the components of an electrical system and how they are connected together.
Yes. So how do we create one? Well, essentially, we're looking at the physical electrical system that you have in your facility or at your work site. And the relevant data from that electrical system gets modeled into some form of engineering software. And there's some pretty common ones such as SKM Power Tools, Easy Power, ETAP. Those aren't the only ones, but those are probably the most common that we've seen
That
used.
I'm aware of, yeah.
Right.
Those are the most common.
Right. So you put all this information in, you show, you've got your utility point, your cables, your breakers, fuses, the transformers, motor,
you name it.
All of that kind of stuff goes into a single line diagram. Now, what about how often it needs to be updated so that it stays useful?
Well, the 70E talks about the arc flash portion of it. And if there's any change to the electrical system, then you must update your study for arc flash.
Right.
But that'll end up changing your one line anyway. So.
Right. Yeah. One of the things about these one line diagrams is that it's really only going to be helpful and useful if it's correct.
Yep. And
so any change you have, whether it be, a different fuse model has been put in place. You had 200 amp FRSRs and now you have 200 amp A60s, whatever. It would change your single line diagram, therefore it's out of date. So you need to get that updated. In fact, in 205.2 of the NFPA 70E, where it talks about the need for single line diagrams, it shall be maintained in legible condition and shall be kept current. There's no timeline. It's just anytime there's a change, keep it current. Because again, everything else that we're talking about is reliant on an accurate one line.
So the poll question said a large enough change.
Right.
It's actually any change.
If it would change the little marking on that one line, that's considered a change. You need to be making sure that keep that up to date. Mark it up, keep it up to date.
If it is a small change and you don't know if it's going to affect your study, your arc flash study,
or short circuit,
then
or
you can reach out to us and we can figure out whether or not it'll change your study.
Absolutely.
Yep.
All right. So, and then of course, every 5 years at a minimum. Okay. So just pointing out that yes, 5 years is still mentioned for a lot of these things. Like in the MTS, it says, if it's been 5 years since your last update, you need to get your single line diagram checked. But it's really a lot more than that. So why is it helpful? What's the useful information you get out of it? Well, it shows how your electrical system's all connected together.
Yep. It can show your physical location of your equipment with the use of text blocks and notes on the one-line diagram. Sure. You can create a riser diagram that does basically the same thing, but by floor. Yep. Floor plans, I haven't seen that very often, but I have seen it before.
Yeah, it just lets you know what you have in your system.
Yeah.
And part of that is also making sure that you know where your upstream points of disconnect are. So it can help with your lockout tagout procedure or, establishing electrically safe work condition. How do you know if there's 2 feeds unless you have some sort of documentation showing that there's 2 feeds? Or, maybe a back feed possible or such and so forth. So it can go towards a lot of work practice help as well.
Yep.
It also can indicate what the overcurrent protection you have in your system is. So like we were saying, breakers, fuses, relays, that kind of stuff. And it can show what grounding system is installed, if any, if that's included on the one line.
It's not typical, but I've seen people include the ground and the neutral in a single line diagram.
Right. But the big point here that we're making is that it becomes the basis for all your other studies that we're talking about here. And so again, if this is not up to date, if this is not current, then none of your other studies are going to be current. All right, and this is what it looks like. It's kind of just a little snippet of one that we've created before for a client. Starts at the utility point, goes through.
At the top there, you've got the utility point.
Yes, yep. Starts at the top and works your way down, kind of like, flowing through the stream, upstream, downstream.
Right. Typically, you'll work from the top to the bottom. Yep. That's typically how the electricity flows, is from the source to the load.
Yep. And it's got a legend. We always put a cheat sheet basically of what the symbols mean. So circuit breakers, fuses, what the wires look like versus transformers.
So you can see all the different components in the electrical system. You can use data blocks that you can provide information from your studies. There's text blocks in there that you can really provide any additional information as well. So very handy tool.
Yes.
To have.
Right. So using that, you can calculate your short circuit current or your fault current. So what's that?
So it's a type of power system study that calculates the available short circuit or fault current at each point in the electrical system.
All right. So how do we do that? We've got our one line diagram, right? So
well, first you'll need some kind of source to initiate the study. Typically, it's a utility contribution from data that you get directly by contacting the utility. They'll provide you the fault current information at the utility point that you saw at the top of the one line diagram in the previous slide. And
if then you run generators, maybe that as well.
Yeah, for sure. And then also the single line diagram itself is needed, which is the modeling of the impedance of the equipment. You'll need that for the calculation as well.
And so that way you start somewhere with the available fault current, and then you know the impedance in your system. So at each point after an impedance component, it can calculate how much available fault current is left, essentially.
Sure.
Kind of.
That's one way to put it.
In a non...
There's many ways to explain it, yes.
Okay, and then the other part of it, when does it need to be updated? How do you keep it, useful?
Sure. So in the NFPA 70B, of course, it's the brand new standard on the block. And Chapter 6, short circuit studies, is now required to be updated not to exceed 5 years.
But if you look one line above that, it says shall be updated when changes occur in the electrical distribution system that could affect the results of the study. So 5 years really is the minimum rule. That's if you live in a fairyland and haven't had any changes in your distribution system, worst case, all you're doing is getting updated utility fault current values.
Right. You might ask yourself, what could affect the results of the study? The MTS has a table in Annex C that shows different circumstances in which could change your studies. And I recommend that you review this because it's very helpful.
Right. And we've typed it out, so it's on the slide, at least for which ones are applicable for each type of study. And Joe, you asked if the copy of the presentation will be made available. Yes, it will. We will make sure that you have this because there's a lot of good information for you to reference in
Absolutely.
here. So 5 years at a minimum, or
Or
You shall update it anytime there's a change that could affect the results of the study. So the whole should versus shall thing, right? A lot of times people have said that it's best practice. It's good to keep up to date on your one-lines and your studies. Well, it's a shall, actually. It shall be updated whenever there's a change. All right, what do you do with the information? Why is a short circuit or fault current study so important?
Well, first of all, what we like to look at is the available fault current for arc flash purposes.
Yep.
We'll get into that later when we cover the arc flash study. But short circuit studies are actually required to even calculate arc flash incident energy.
Correct.
And then also we use the available fault current information to determine whether your overcurrent protective device or devices is rated to be in the system, which is actually an NEC code requirement.
Right. The interrupt or the AIC rating.
Yep.
Yeah.
So it must meet or exceed, the rating of the device must meet or exceed the available fault current of the system. And
that's kind of a big deal. It sounds, if you don't really know what that means, it sounds kind of confusing, but it's a huge deal, because what happens if you don't have the proper rating? What if it's like way underrated to the available fault current in the system?
So essentially is you want your overcurrent protective device to operate safely at the available fault current in the event there is a fault on the system. If the device is rated lower than what's available in the system, it might operate unsafely, or in other words, there could be an electrical explosion.
Right. So it's very important to have this data. It's not, a nice to have. It's highly important, because if something were to happen, you want your devices to clear the fault rather than exploding because of the fault.
Yep.
Yeah, let's avoid that. All right, so here's a result of what a short circuit or fault current study might include. And this one is provided by using the SKM Power Tools software.
Yep.
So basically, you want to talk about how to interpret this data, or kind of quickly run through some of the information?
Sure. So in engineering terms, there's several different fault current studies you could do. You've got single phase, phase to phase, 3-phase, bolted fault current, short circuit studies that are done. And all of this information for the system is put into a report, nice and neat, like you see on the screen here. So you can reference it anytime. Yep.
All right. Moving right along, coordination studies. That's the next one in the list that we get from 70B. So what is a coordination study? Well, what we've kind of put here is it's a technique of designing protective systems to operate protective devices closest to the fault open first, while protective devices farthest from the fault open last. So if you think about that one line diagram, top to bottom, right? You've got a motor down here, and it has a fault. You've got 3 levels of protection, right? You've got your disconnect right above the motor, and then maybe a breaker, and then let's say the main disconnect for your facility. You want that motor disconnect to operate and clear the fault.
Closest to the fault, right?
You don't want it to go all the way through your system and operate the main circuit breaker fuse.
You don't want to shut off your entire facility
just because one motor, right?
One branch circuit.
Or whatever it is, right? So the point is, we want it to coordinate so that you don't have unnecessary outage areas. So how do we perform this? Well, it's, again, typically performed with an engineering software of some kind. There's a little bit of a theme there.
You'll need to model the single line diagram.
Yep.
You'll need to run short circuit studies.
Yep.
And determine the maximum available fault current, as well as the arcing fault current, which is different than the maximum, or 3-phase bolted fault current. And then you'll also need to know the protective device, characteristic data, so you can model the TCC or time current curve diagrams. And then typically those are analyzed by an engineer to selectively coordinate the system.
Basically looking at it and making sure that they're in the right order for the fault current scenarios that you're evaluating. And we'll show you what we mean in just a couple more slides. We have an example of one that was not coordinated well, and then after some analysis, what the curves would look like if it was coordinated well.
Right.
And when does it need to be updated? Guess what? It's going to be pretty similar to what we've been saying so far. Yes, at a minimum of every 5 years, or if something has changed, to make it no longer adequate. It's not up to date anymore.
The MTS is helpful.
It very much is.
I'm telling you.
Honestly, anytime you have a different type of fuse, anytime you've adjusted a setting on a breaker or replaced it, if you have different impedance components, lots of things could change and make your coordination study potentially false.
Right.
Okay, so why is it helpful? How to use the information? We kind of already touched on this a little bit, but it does help improve system reliability. That's kind of a nice way of thinking about that.
Right. So reliability focuses on the continuous delivery of power. And if you have a system that's not coordinated, like we talked about, and a single branch circuit shuts down your entire facility, naturally having a well-coordinated system improves your reliability.
Right. Which, again, goes hand in hand with minimizing that outage area during those short circuit or faulting conditions. Also can help minimize the downtime.
Yep, just talked about that.
Yep, and reduce arc flash hazards potentially. So part of mitigating an arc flash hazard using, engineering controls, looking at your breakers, your fuses, stuff like that, you have to be able to provide recommendations that don't affect your coordination. And also sometimes coordination studies, the recommendations from those result in lower arc flash hazards as well. So they do go hand in hand. So Joe, earlier you said coordination study done with arc flash. It makes sense to do that. Not everybody does though. But yes, it makes sense.
Actually, you should do that. If you have any protective device above 1200 amps, according to NEC 240.87B, I believe it is. I'm just throwing that out off the top of my head. What's talked about a lot is coordinating between protective devices. But according to 240.87B, you should actually coordinate devices above 1200 amps with the arcing fault current of the system for arc flash mitigating purposes.
Right. Okay. All right, so here's that example that I was talking about. So TCC curve, or time current characteristic curve, of each protective device is plotted on this log chart.
TCC.
Yes. And basically, the super high level, gonna make engineers mad version of talking about this, we've color coded it and we don't want the colors to overlap. And we want them to be in a specific order. Now, again, that's a super simplified version of saying that, but just for your sake of looking at these, the one on the left is very clearly not adequate because we want the blue to be furthest to the right and not overlapping with anything, because otherwise you're going to have a much higher outage area than necessary. And we want the orange furthest to the left and not overlapping with anything, so that its direct feeds are the only thing that it's going to, need to worry about operating. So left to right, much improved coordination. Mind you, again, huge disclaimer, there's a lot more to it than that, but that's kind of the 1,000-foot view.
For instance, the curve in blue is 1600 amps, so that would fall under the 240.87 rule for any device over 1200 amps.
Yep.
Unfortunately, we didn't show the arcing fault current line on this, but if you want, I can send that to you later and we can talk more about it.
There we go. All right, moving right along, load flow studies. We have 3 more to get through: load flow, reliability, and arc flash before we get to module 3. So load flow studies. Power system study used to calculate power flows. Go figure. The name.
Yeah.
Go figure. Voltage levels and voltage angles of lines and nodes in a power system. And if you don't know what voltage angle means, then that's okay. You don't need to. Just get an engineer to do it for you. All right. So that's kind of what it is on a technical level.
High level, yeah.
What do you do to perform it?
So again, single line diagram.
Yes.
Typically performed in an engineering software.
Again.
Because nobody's really doing these by hand anymore.
Yeah.
It takes too long, and if you do it by hand, it's too expensive.
Yeah.
To do it. So first, you'll need some input data for the study. You'll need the generation or generator information, load information, and the impedance data to model the single line diagram. but all this information will be used in the study, and protective device and switching devices aren't used in the study, essentially.
Right. That's not the point
So
of the
it's just
study.
kind of a basic explanation of load flow studies.
And guess what? When you need to update it is pretty much the same as what we've been saying all this time. Every 5 years at a minimum.
Yep.
But shall be updated anytime there's a change that could affect the results of the load flow study.
Mm-hmm.
It's consistent. That 5 years really is a minimum.
Mm-hmm. So 70B and MTS sometimes go hand in hand.
Absolutely. All right, so why is it helpful and how do you use the information?
So some basic benefits of load flow studies are monitoring your load across your customers. So you can imagine utilities use these studies quite a bit,
right,
for delivery of power. Power factor correction can be modeled. So adding capacitors to your system to see how the power factor changes.
Sure.
That can easily be done with a load flow study. And you can look at total power factor losses, and loss reductions can be calculated from that information. So that could be used for budgeting purposes. Right. Again, probably highly utilized by utilities.
Yep.
And then also inspecting your system capacity and using your system efficiently.
Right. It can help figure out where you might be losing power unnecessarily and rework the design of your system so that you're being more efficient.
Yeah. It can also tell you if you have enough capacity to add equipment.
Right.
To your
That's
system
true. That's
well.
true.
So.
Yeah, that's a big piece of whenever you're doing like a major renovation, you're doing an expansion or something. This would be a good study to consider doing ahead of time.
For sure.
But again, you should be doing it anyway.
Yep.
And not to exceed 5 years anytime there's a change. All right. This is one example of what a load flow study might look like.
Well, this is only 3 buses, but
it's a very small study. But
in reality, the study is going to be much larger than this. So
right.
If you just imagine what your one line diagram looks like, you'll probably have multiple buses. But this is just a basic example of what a load flow looks like. You can see with the green arrows, the flow of power in the system. You can see the voltage angle, the per unit power factor, and power. Yeah. Megawatts and MVAR. Yeah.
Yes, indeed. All right, moving right along, reliability studies. So this is one that isn't mentioned in nearly as many or in as much detail. However, it is incredibly useful and important for a lot of reasons. And so we're going to spend just as much time on it, even though we're not pulling from the 70B, for example. It just mentions that you need to do it, right?
Right.
So what is it? What is a reliability study?
Well, it's primarily used for planning purposes, to calculate distribution system availability, but primarily failure rates is what I know that it's primarily used for. Loss of power costs can be calculated from there. Reliability studies calculate the probability of electrical equipment failure before the time intended to utilize the equipment. So essentially, that can be very helpful in determining whether your equipment is about to fail for safety purposes. Right. You wouldn't want your workers working on equipment that's about to fail, because that might harm the workers, right?
Oh, for sure. All right. How is it performed? Well, you guessed it, typically performed with engineering software assistance, using some sort of data. What kind of data are we looking for?
Okay. Again, the single line diagram will come in very handy here for documentation purposes. But for simple reliability studies, or the basic fundamentals that you'll need is to know the system design and the installation, the selective coordination of the system. Like we talked about earlier, a well-coordinated system will improve your reliability. Proper equipment maintenance. We talked about condition of maintenance there just briefly, and also proper system operations are required. So all this information is used to predict the failure rates of equipment for the reliability study.
Yeah.
Yeah.
There's a lot of detail that goes into this. It's not super subjective or anything. It's based on hard data.
Yep. A lot of data goes into a reliability study.
Yeah. All right. So how is it useful? Kind of already touched on it. Basically helping predict failure of equipment in a given time period to limit system downtime so you can react accordingly. It's, again, going kind of in a predictive maintenance world. Is performing these reliability studies rather than reactive maintenance, so to speak.
The more data you have, the more predictability you'll have for the failure of your equipment, essentially.
Yep. So you can help identify and improve those potentially weak or unreliable parts in the system. All right. Here's a snippet of what a reliability study might look like in an engineering software program.
So this is ETAP, and I got this from their website. It's the fastest single line diagram that depicts the failure rates of equipment on it. And again, the single line diagram is very useful in documenting studies.
All right, last but not least of the ones we're talking about today is that arc flash study. So it's a component of your arc flash risk assessment used to predict the incident energy of an arc flash for a specified set of conditions. So basically, it helps you identify how bad an arc flash hazard might be under a very specific set of conditions, though, because again, it's reliant on that data being accurate that you've fed into the model for the calculations. So how do you perform an incident energy analysis? Well, that physical distribution system information gets put into a one-line diagram using engineering software.
Starting with the one-line diagram.
We oftentimes use SKM Power Tools. We've also gotten into Easy Power. Whatever you're comfortable with, that's where you put it. And that's going to be a lot of your impedance components and your overcurrent protection. You'll start with those utility fault current values and then calculate that available fault current
Gets
at
into
each.
the short circuit study that we talked about, which is required for the arc flash.
Right. That's a major component in the calculations for an arc flash study. So you have to do the short circuit first, and then you can do the arc flash analysis for the incident energy analysis. And then that way you can get the potential available incident energy for each location in your system. So each means of disconnect, anything that's going to be likely to require examination, adjustment, servicing, or maintenance while energized per 70E and the National Electrical Code. And then we produce a label to help label that hazard and warn personnel of those hazards and what to do to protect themselves, how far out the hazard goes. So where do you need to put your boundaries? What do you need to wear whenever you're in those boundaries? All that information goes in that study result. And when do you need to update it? It's going to be the same as everything else. At a minimum of every 5 years is what it says. Shall be updated at a minimum of every 5 years. Or any time that any component in the system that was used to calculate the results has changed. If there's been an update in your system, a setting change, a fuse change, you've rerun equipment to something else, or you've sized up or sized down your conductors, there's all sorts of things that could cause a pretty big change in the results of your arc flash study. And so anytime that happens, from the point of that change downstream, the rest of that section of the one line, you really shouldn't be looking at those labels anymore until you verify that they're still accurate or get them replaced. Oftentimes, a couple of them will need to get replaced or more. John asked a good question, and I think this is a good time to go ahead and answer it. Has there been a time where local power company updated their equipment to increase fault current levels and let people know? Did you get a heads up? Well, no. Yes, actually, that's twofold, two questions, right? So yes, things change in the utility contribution all the time, especially because we're connected in a grid. So maybe it's that the utility company has changed their operation, their means of power distribution, right? And that can, of course, change the amount of available fault current
Utilities
at your
are
facility.
adding and removing customers all the time.
That's the other point.
So the load they're delivering will affect their contribution to your system, whether you know it or not. Whether you make a change to your system at all, the utility is always making changes.
Oh, for sure. Now, the idea is whether or not there's going to be enough of a change to cause your overcurrent protective devices to react differently. Maybe they trip slower.
Mhm.
If you have less available fault current, that's potential. Or if you get over a certain threshold and you just keep going up and up and up in the available fault current, your hazard can get worse and worse, right? So unfortunately, most of the time, they're not going to give you that heads up. You have to request that information on a regular basis.
Yep.
So let's go back and live in that fairyland for a moment. You've changed nothing in your facility. You still need to get your arc flash and your short circuit studies and everything updated every 5 years at a minimum. Okay. That's because you don't have control over that utility contribution for the available fault current.
Just another thing
And
we
they
can
don't
blame
just-
the utility for.
And they don't just give you that information. You have to ask for it. So definitely got to keep that in mind as well. Good question, John. All right, why is it helpful? How do you use the information? Well, this one hopefully is a little bit more understood by people, but still, it's going to give you what the available incident energy is at a location if an arc flash were to occur. So it'll give you that incident energy, the arc flash boundary, again, how far out the hazard is so that people know how to set up their barriers and barricades appropriately, or station an attendant outside of that boundary to keep people away. It'll help identify what PPE is required, the minimum ratings of those PPE articles that you're going to wear and rely on, as well as just making sure that your voltage levels is also going to be included on these arc flash labels.
The first bullet point is straight from NFPA 70E 130.5H.
Yes.
Which is actually required information to be shown on an arc flash label. And the worker will be reading this information anytime they're working on or around the equipment.
Yes. And then, of course, the other reason why it's helpful is that you remain compliant with the codes and standards that require it. So there's that.
Yeah.
And here is what the results typically are going to look like. At least this would be an example from one of the studies we've done. So those warning and danger labels, maybe you've seen those on equipment before. That's the main goal, I think, for a lot of people, is just to get those labels on equipment so that workers are aware. They approach a piece of equipment, they know exactly what they're going to potentially be facing. Still do a risk assessment.
I need those labels now.
Absolutely. No, it's a matter of worker knowledge and awareness of how to be safe. So I get it. There is an urgency for that. But there's more information besides just the labels that come from an arc flash study being done. You still get those one-line diagrams, which have a lot of good information, including that short circuit information. And you get this nice analysis summary that explains the different parameters and results that you have in your study.
The study report is what we call it.
Basically.
So, yep.
All right. Before we move on to the last part, let me go ahead and launch this poll of, are you confident that your electrical system studies are accurate and up to date? Let's see. And while you guys are answering that poll question, Kenneth asked, do the labels date have to reflect the updated study, i.e. new labels? There is not a requirement for that necessarily. It's a good practice so that everyone is perfectly crystal clear of when the last time this study was evaluated. But technically, if there's been an update in your study and the results had no change for the data on that one label, then you don't have to replace that label. The update, if it reveals any changes, those labels have to get changed and replaced. Okay, so no, you don't technically have to have the same date. It's just kind of good practice to make sure that you have.
I'd say it's helpful to review what equipment hasn't been updated within the last 5 years, for sure.
And then Brenda gave experience. John, we have experience having the local utility make a change and not alert us. Unfortunately, very common. ahead of the next study due. So our related calculations and labels changed. Yep, that definitely happens quite a bit, which is why the minimum of 5 years, even if you've not changed anything internally, is so important.
Right.
And John's saying it sounds like may need to add an annual utility company fault current chart in my electrical safety manual. That's actually not a bad idea, is checking in more frequently just to make sure that nothing's changed too much. Depending on where
that's something the MTS recommends for generation and transmission organizations. It's not required by any means to do that. That's just recommended.
Right.
So that would be a should, not a shall.
I will say, though, a little caveat to all this conversation about the utility, there are some areas and some utility providers that are very difficult to work with as far as getting that fault current contribution. Yes. Or there are some companies that have gone to doing a table, an average, fault current for this type of system rather than giving specific values. And in those situations, it's probably better to just go ahead and do a worst case estimation instead. Just in case what they've given you is really not as close as it should be. That's
not ideal. Ideally, you'll want actual conditions. But then again, what does that mean? Since the utility is changing all the time, they usually provide a maximum value or a minimum value from the system from the past year, which typically is a pretty good conservative method to use.
And it does affect a lot of these studies, if not all of them. So having accurate incoming power data is going to go a long way. Okay. Looking back at this poll, thank you guys for answering while I was talking away here with James and Brenda and John. Yes, all are good as far as keeping your studies up to date. That's fantastic. We had some people say that. No, some are up to date, but some are not. That is the majority of what people have answered. Totally fair. Kind of figured this would be the result, that most people are somewhat there, somewhat not, depending on what the study is. Hence why we wanted to do this webinar. And then no, we need to get on that. So for those of you who just have not known about it previously, now you do. Now you know what to do. So to recap this second piece, the big meat of this presentation for you today, the electrical codes and standards mention the need for system studies to be completed, but they also require them to be completed minimum of every 5 years or any time that there's something that has changed, because waiting till that 5-year mark, it really can be dangerous. You could be relying on false and inaccurate information. You could be having lower PPE requirements, for example, than what's really needed because the incident energy has increased, because you've made a change, because. All these things drastically change your short circuit studies, your arc flash studies. It can change your reliability and load flow studies and coordination as well. Did I get them all?
It can change all the studies in chapter 6 of the 70B.
It can change them all. So got to make sure that you keep them up to date. So anytime there's a change that could alter study results, you should be reviewing and collecting that data and getting it updated as best as you possibly can.
Right.
Okay. So module 3, what should we do now? What now that we have this information, we know what the studies are, some pretty basic guidelines as far as how they're completed. What should you do? Well, it's kind of similar. If you listen to our 70B webinar, our call to action is pretty similar. It's just audit and update your system, right? So for 70B, it was audit and update your preventative maintenance plans. But now we're saying audit and update your electrical system studies and your single line diagrams. So review what you've currently done and make sure that they're completed within at least the last 5 years. Get that bare minimum requirement taken care of within at least 5 years. Okay, so that's number 1. And then if you've identified studies 5 years or older, of course, get those updated. If you have stuff that's done within the last 5 years, so that bare minimum requirement's already taken care of, still go back and audit your equipment to make sure that it all lines up still and that parameters haven't changed since the latest version of your diagram or your study. Get those truly out of date 5-year or longer ones done first, and then tackle the ones that are within 5 years but maybe have a change and therefore are not in compliance either. Got to keep up to date with them.
Right.
All right, so that is the end of the meat of this presentation. We want to dive into the Q&A in just a little bit. Dave is going to hop back on here and give you a little bit of information, remind you about the next month's webinar, and then we'll get into that Q&A. So go ahead and start typing out those questions for us.
Hey guys, nice to see you again. Yeah, so if anybody has any questions, last minute questions, ask them right now in the chat bar. But a reminder that at Hersing Engineering, we do arc flash. This is the majority of our business. So everything that was talked about today is included in a typical arc flash study, report, analysis, risk assessment, and we would love to be able to be your providers. I know as safety leaders or maintenance supervisors or risk leaders, you guys know what needs to be done most of the time, and when you know it's not being done and loose ends are there, you worry about the worst. We all do, and it's okay, but we can help you tie up loose ends. So go to hersingengineering.com to request an arc flash study and report, and we'd be more than happy to help you. We are pioneers in the industry. We actually started before a lot of these regulations came about. So we've have the experience, 23 years, plus we've done thousands of studies. So we'd be more than happy to get you the most accurate labels, one-liners, short circuit studies out there in the industry. So it would be our pleasure to partner with you all. I do have one last poll question for everyone. And the question is, when talking about electrical system studies, what is the most important factor in your opinion? So I'm going to load that poll up right now and see what you guys think. When talking about electrical system studies, what is the most important factor right now? Confirm that equipment is efficient as possible, keeping data up to date for future renovations, or having accurate info for safe work practices. What would you guys say? Go ahead and fill that out, and then if you have any more questions, as you guys are filling that out, I do have a question, guys, for Caitlyn and James. Remind me, so for like a coordination study, short circuit study, did you guys say that that is required now, and where is that found? Is that the 70B or 70E?
Yeah, so the short circuit studies and the coordination studies, honestly, all of the ones that we've mentioned today are in Chapter 6 of the NFPA 70B, the 2023 edition.
Which is now a standard and shall be followed.
done. Yeah, so each one of these is Chapter 6 is single line diagrams and system studies. So for single line diagrams, it says shall be maintained, shall be kept accurate.
Yep.
And then short circuit studies, kind of the same thing, shall be updated, shall be reviewed, intervals not to exceed 5 years or anytime there's a change. It says the same thing for coordination studies, load flow studies, reliability studies, and the arc flash analysis. There's also a 6.8, just to throw it out there, electrical maintenance related design, that you need to be reviewing all of these studies and the information anytime before you make a change as well. So that's what they're saying there.
And then we have Keaton. He asked this earlier on. He said, would this include IR screenings and or on breakers?
Yeah, that's a good question. You know, whenever you're talking about analyzing electrical systems, infrared's a hot button topic, and it's very important to do. That's not quite what we're talking about here. We're talking about being able to do some sort of system study that kind of boils down to an engineering calculation, right? Infrared scans are just a little bit different.
So the infrared scan will fall under the new 70B.
For sure.
It'll be considered an electrical inspection test or an electrical test, and it's typically a non-contact test. I'm sure you know what infrared is, but if you refer to Chapter 7 of the NFPA 70B, it goes over the infrared portion and requirements for that type of testing.
Right. 7.2.1.1 specifically.
Yep. Very nice. The last question I have for you all is, you know, I guess the best way to get these codes and standards is to get those books that you have in front of you.
Yes. For reference of everything we've talked about today, we highly recommend bare minimum getting the NFPA codes and standards. So the NEC, the 70E, and the 70B. Yep. And those can all be found on the NFPA website. You can purchase physical copies of them. I don't believe they sell digital copies anymore because they'd use the NFPA link is what they call it. It's an online access that's super nice and efficient and
all you do is
smooth.
create an account with nfpa.org and you'll get free access to all their codes and standards.
Right. Yeah, their free access online is a little bit different than the link, I will say. The free access online is nice because at least you can see it. You're flipping through page by page. It's not the most user-friendly, but then if you do the subscription for link, then it's super nice and easy to use, and you can go to whatever you need to at the drop of a dime.
I prefer the physical book. Call me old-fashioned.
Yeah.
I think most of us do.
And then the MTS is going to be just available for purchase.
Yep, this is not required, but it is recommended that you refer to this for maintenance, testing, specifications, as well as circumstances in which you should update your system studies that are in the 70B.
Which is any time that there's a change that could affect the results.
Correct.
Not just every 5 years.
Love it. Well, thank you guys so much for joining us. Everybody online joining us, thank you so much. There is a handout in the handout section on the top right-hand side that you can download this PDF for your records. Later on, after this webinar today, a replay will be sent out, so please share that with your team or anyone who wasn't able to make it today. On the screen, you have a contact information for James and Caitlyn, as well as a way for you to request a quote for an arc flash if you are out of compliance and you just know that you need to get some of these studies done. We'd be happy to chat with you and head to your facility to help keep them, the workers, compliant and safe. What we're going to do is we're going to leave this chat open for just a little bit longer so you can screenshot this slide right here. But James and Caitlyn, thank you so much for joining us. Great to have you on as always.
Yeah, thank you guys.
Yep. Thank you everyone for attending today. It's great to have you.
Always appreciate having an interactive audience as well. Makes it more like a community.
And congrats to
John,
James for
Travis.
his PE
yes,
license.
Congrats to James on getting his PE. Big achievement. Yay.
That's right.
Very nice. Very nice.
Thank you guys.
It's nice to have that afternoon.
All right. Bye, everyone.
Bye.